Hello friends, I welcome you all on India's largest live e-learning educational platform, that is Gradeup. All the candidates who are joining me, just quickly confirm whether my audio and visual quality, everything is clear. All the candidates who are joining me, just quickly confirm whether my audio and visual quality, everything is clear. Just confirm whether my audio and visual quality, everything is clear. All the candidates who are joining me live, just quickly confirm whether my audio and visual quality, everything is clear. Now, till you report me this, let me just brief you about the session, what we are doing in this session and what we are trying to achieve. Friends, we are discussing the important topics for your coming gate examination, and we have started this series some days ago, and daily 9 p.m. the evening we are discussing the important concepts, theoretical detail, and we have already completed 3 lectures in this series, and this is the 4th lecture. And I will be trying my level best to complete the testing of DC machines in just 45 minutes. Within 45 minutes, our aim is to understand the conceptual understanding of the backup for testing of DC machines. So all the candidates who are watching me live, just quickly confirm whether my audio and visual quality, everything is clear. Vaibhav Chaudhary, good evening, beta. How are you? Welcome to the session. Just quickly confirm whether my audio and visual quality, everything is clear. Everything is clear. Okay, let us start with the session without wasting much time because we have very limited time. When you talk about the testing of DC machine, first thing we have to understand that why we want to test our DC machine. This is the first reason. The answer is to check the performance of DC machine in case of actual load condition without actually putting the machine under the load. This is our intention. We want to understand what is going to be the performance of machine once it is handed over to the final consumer. So that is why you want to test your machine, whether it is a generator or motor. Our intention is that we will not actually load the machine, because if we are going to load the machine, you can assume we are not going to manufacture just 4, 5, 10 or 20 machines. We are going to manufacture hundreds and hundreds and thousands of machines. So if every machine we are going to put under the actual load condition to test its performance, then it is going to be very lossy. Losses are going to be there and it is going to be uneconomical. So you can understand logically, we should not put our machine under the actual load condition, and still we are trying to get its performance under the actual load condition. High entertainment and education, great name. You are having a contrary name, entertainment and education together. It is very difficult to achieve. Now, if you see the testing of DC machines, we have basically 5 methods. Number 1, break test. Number 2, Swinburne test. Number 3, Hopkinson test. Number 4, field test. And number 5, Number 5, retardation test. Retardation test. So let us start with the first test, that is the brake test. Hi Mohammad Nafis Khan, how are you? Welcome to the session. Now when we say brake test, it means suppose you have a motor. Suppose you have a motor like this. Suppose this is your DC motor. This is your field winding. And this DC motor, suppose you are going to connect to a brake drum. And this brake drum you are going to connect. Brake drum you are going to connect with two spring balances like this. You are going to connect with two spring balances. Suppose it is S1 and this is S2. Suppose this is S1 and this is S2. Clear? Now we are putting some variable resistance in the field winding RH. This is the shunt field. And there is going to be some armature resistance also. Now, suppose the radius of this brake drum is small r. Now, if you see, the purpose of this brake drum is that your motor wants to rotate. Your motor wants to rotate, you are applying some voltage, but this brake drum does not allow your motor to rotate. Are you getting this idea clear in your mind? So what is happening? Whatever current you are going to draw, suppose this is the line current and this is the shunt field current, and suppose this is the current in the armature, suppose IA. So what is the power input for this machine? What is the power input for this machine? Power input from the supply you can calculate multiplication of voltage and the current. So this is going to be V into IL. Now this is going to be the input power. Output power you will be getting if you have the readings of these spring balances S1 and S2. So if you want to calculate the shaft power, first you have to calculate the shaft torque. This is going to be the shaft torque. How you are going to find the shaft torque? It is equal to 9.81, the difference of the spring balances, and multiplied by the perpendicular distance, that is the radius of the brake drum. This is the radius of brake drum. This is the radius of the brake drum. Everybody just confirm, are you able to follow this or not? If you have the shaft torque, can you write the shaft power? This is going to be shaft power. Yes. Very easily you can write the shaft power, shaft torque multiplied by the angular speed as 2 pi n by 60. 2 pi n by 60. Now this speed is speed in the RPM. This speed in the RPM you have to calculate in terms of omega as 2 pi n if n is going to be in RPS, and this if you write in terms of RPM it is going to be like this. Now if you have the output at the shaft and if you have the input, then very easily you can write the efficiency. Efficiency is going to be P shaft upon P input. P shaft you have just calculated as shaft torque multiplied by the speed, that is angular speed, and input power you have calculated 9.81 the difference between the spring balance and the radius of the breakdown. If you multiply it by 100, you will get the efficiency in percentage. Now this speed you can find by using a tachometer. This is how you are going to calculate the efficiency by using the brake test. But if you see the brake test, because you are not allowing the motor to rotate, it means whatever power you are taking from the supply, it is going to be wasted. So generally this test we are performing only for small size machines. Small size machines. For large size machines, it becomes uneconomical. For large size machines, it becomes uneconomical. Everybody just tell me, are you getting this idea clear in your mind? Yes or no, just tell me whether you are getting my point clear in your mind or not. Now there is one advantage also. The advantage of this method is that if you see by applying this breakdown, you are actually putting the machine under the load conditions. You are actually putting the machine under the load conditions, so you can have accurate analysis of armature reaction and commutation. Actual analysis of armature reaction and commutation. Yes, only one candidate is responding, that is Nafis Khan. What about other candidates? Now some of you may be asking, sir, you are saying this is the testing of the DC machines, but when you started discussing the brake test, then you are talking about DC motor. What about the generator? Now you can perform the same test for the generator also, but for the generator, the circuit is going to be different. If you want to perform this test for the generator, then what you are going to do, suppose this is your motor, this is your shunt field, this is your terminal, and here you are connecting a load. Now this load is a dummy load. Dummy load means it is not going to serve any real purpose. Okay, it is just that you want to check the performance of the machine. This is going to be terminal voltage, armature current because it is a generator. This is the load current, this is the shunt field current, and this is the shunt field resistance, and this is the generated EMF. Now you can calculate the power absorbed by the load as PL. Okay, and the input power you have to find from the prime mover. With the help of prime mover, if you are rotating the generator, suppose in this direction, okay, so suppose this is the prime mover input power, and PL is the power absorbed by the load, and you can find the efficiency by using the output power and input power. Okay, now let us talk about the Swinburne test. Swinburne's test. Swinburne test, let us have the circuit first. The circuit is going to be like this. Swinburne test. Sorry. Again, let us take the case of a motor, and let us take the shunt motor. For the simplicity, we are taking shunt motor. Now, again, suppose we want to show that this Swinburne test is performed in case of no load. We want to show that this Swinburne test is performed in case of no load. That is why we are showing the breakdown, and we are representing this belt of the breakdown as loose. That is, we want to say that it is the no load test. So the first thing about the Swinburne test, you have to understand that it is a no load test. The moment you listen that it is a no load test, you must understand that this test you cannot perform, can't be performed. Yes, Sukanya, you are right. Performed for series motor, because you know that for series motor the no load speed is going to be very dangerous. DC series motor. This is one thing. Now, what is the logic behind this Swinburne test? The logic behind this Swinburne test is that losses are calculated first, and then efficiency can be calculated at any load condition. Okay, this is very, very important to understand this particular test. Okay, now you are saying, suppose this is the line current, this is the shunt field current, and this is the current taken by the no load condition, taken by the motor in case of no load condition. Now if you see, you are saying S1 and S2 spring balance readings are 0 because it is a no load condition. So if you see the shaft power or output power, it is going to be 9.81, 0 difference 0 multiplied by R, so it is going to be 0. It means shaft output power is going to be 0 because it is simply no load. So whatever power you are going to draw from the input, it means the total input power is going to be wasted as losses in the machine. वेद कुमार गौतम, बेटा ये क्वेश्चन नहीं करवा रहा हूं मैं, ठीक है। अब ये समझते हैं सब पहले कि मशीन में इस समय लॉसेस हैं क्या क्या, ठीक है। नो लोड कंडीशन में इस समय लॉसेस हैं क्या क्या मशीन में, ये पहले समझ लेते हैं। जितनी इनपुट पावर है वो कहां से निकल जाएगी? अगर आपके पास टर्मिनल वोल्टेज है और करंट है तो आपको इनपुट पावर मिल जाएगी। यू विल गेट द इनपुट पावर एज V into IL, equation number 1. What are going to be the losses? Now if you see the losses you can write as P losses is equal to rotational losses plus there are going to be shunt field losses plus variable losses. Now variable losses are going to be IA naught square RA. This is the armature circuit losses and these are the variable losses. How you are going to find this VISH? This ISH you can calculate as IL minus ILO. This ILO is nothing but the armature current in case of no load condition. So you can find the shunt field current, supply voltage is applied to the field, so you can find the losses in the field winding. Okay. Now from here These rotational losses along with field losses we are calling as constant losses. Constant losses. And what are these rotational losses? These rotational losses we are defining as core losses plus friction and windage losses. Friction and windage losses. These are together we are calling as rotational losses. Now, from here, if you have to find the rotational losses along with the shunt field losses, which we are calling as constant losses, what is this input as the total losses? You can calculate, and you can calculate the variable losses also. IA naught you can measure from the ammeter, and RA you can calculate by Kelvin's double bridge. Why Kelvin's double bridge? Because RA is going to be a very small voltage. We are going to use Kelvin's double bridge method to calculate armature resistance. Clear? So from here you can find the rotational losses PR plus V into ISH as constant losses, that is V into RL input power minus IA naught square RA. This is one thing. Are you getting this? Now, suppose you want to operate your machine for full load condition. Now, for the full load condition, the variable losses are going to be changed, and variable losses you can calculate RA will be changed because of the temperature effect, because when you are operating your machine on full load, the temperature is going to rise. So definitely temperature rise will take some effect on the armature resistance also. So at a particular temperature, you can calculate as RA naught 1 plus alpha delta T. So you can use the modified value of the armature resistance. See, we are finding the losses. We are finding the losses still here by using the Swinburne test. But the logic of Swinburne test is that first you calculate the losses and then you can find the efficiency at any load condition. So our intention was that we will calculate the constant losses first, and variable losses you can calculate for any load condition. Because of the full load condition or any other load condition, the effect of temperature you have to take to have the modified value of the armature resistance, and by using the I square RA you can find the variable losses. For example, you want to find the losses in case of full load condition. Now constant losses are not going to be changed. Suppose these are the constant losses, and variable losses are going to be IAFL square RA at temperature T. Are you getting this? Entertainment? Are you getting my point? Clear? Now suppose you want to find the efficiency. So how you are going to find the efficiency? Suppose you want to find the efficiency at full load condition. Okay. How you are going to find the efficiency? What is the output? Output is going to be total input V into IL minus losses. What are the losses? Constant losses plus variable losses are going to be this much. So it is IAFL square I am writing armature resistance RAT as simply RA. You can understand. If data is such given in the problem, then you have to take into account the temperature effect also. And it is divided by the input power, that is V into IL, multiplied by 100. You will get the efficiency. Okay. But when we were discussing the Swinburne test, we have said that you can find the efficiency at any load condition. Now suppose you want to calculate the efficiency when this current is X times the full load current. We are talking about armature current. It means loading is X times full load condition. Then how you are going to find efficiency as X times full load condition? What is going to be your input? Input is going to be V, and this is going to be X times I full load minus, this is the total input. And what are the losses? Now constant losses are not going to be changed, and the variable losses or the copper losses, you can write it like this: X square I FL square RA multiplied by 100%. So at any load condition, when the current is X times the full load condition, you can use this formula and you can find the efficiency by using the Swinburne test. If you get a numerical question on this in the gate examination, then he will be giving you everything: the voltage, current value, the loading condition, and some data to find the constant losses. So you can calculate the efficiency at any load condition. Now there is a big disadvantage with this. Number one, the problem with the Swinburne test is, number one, cannot be used for DC series motor as it is a no load test. Second, actual load condition is not tested. You are not testing the machine at actual load condition, and you are simply calculating the losses. You are assuming the losses by using the equations. It means it does not take account the commutation and armature reaction. So you can very well say that Swinburne's test is less accurate than Bragg test, because in the Bragg test you are actually putting the machine under the load condition. Everybody just tell me, are you getting this idea clear in your mind? Yes? All the candidates who are joining me, just quickly confirm. Clear? Okay with that? Now, in the next class, today we'll be stopping here. In the next class, I will be discussing the Hopkinson test field test and the retardation test. Okay, because if I start discussing Hopkinson test, we will not be able to complete it, and this is going to be little complex and lengthy. So I do not want to just make it as it is. So let us discuss it tomorrow. Tomorrow, along with the current topic, we'll discuss these three tests together. So thank you so much, friends, for joining me in this session. But before we go to the climax of this session, a very important information for all of you. Now, friends, till 30th of January, if you are interested to finally give it a push to your GATE preparation, GATE 2021 preparation, the Gradeup has opened its doors for you, that you can join the Gradeup course or the Rank Up course. In the Gradeup course, we are discussing the theory, and in the Rank Up course, we are discussing the questions. Now, when you come to the 2022, that is the next year GATE examination, next, then Vision 2022 is for you, where we are discussing theory, question, and everything in the electrical engineering. This is going to be the most exhaustive course, 850 plus hours of live classes, 8,000 plus practice questions, 100 plus mock test, and 120 plus chapter-wise study notes. So if you have any further query, you can contact this number. I think you are going to be assisted in the best possible way. These are the faculties in the Gradeup Electrical Department who are going to mentor you for your coming preparation cycle. And my friend, this is the results we have produced over the years. Top rankers we have produced since 2018, and 2020 has been a great year for Gradeup students. We are 60 plus Gradeup students have topped in the 100 rank. And this is about Gradeup Super subscription. For example, if you take the Gradeup Super subscription, you will be getting access to all the structured live courses. What does it mean? It means, for example, if you want to join Vision 2022 for the next year, for the GATE 2022, okay, then it is not that you have to take separate admissions. No, just one super subscription, and you will be getting access to Vision 2022 also, Rank Up also, and Gradeup also. It means not only you are securing your seat, your preparation for next year, but you can also perform well in the GATE 2021 if you are going to join Gradeup and Rank Up courses. And this all you will be getting in just one subscription, that is Gradeup Super. Along with this, you will be getting access to the Gradeup Green Card. That is, you will be able to access all the online mock test series, which are designed by the toppers based on the latest exam pattern. For any further query, you can contact our backend team. They are going to help you with that. Okay. So thank you so much for today. Let us stop here and let us meet again tomorrow. Tomorrow we'll be discussing the remaining methods, testing methods of DC machines along with the tomorrow's topic. You can check the tomorrow's topic on the Gradeup YouTube channel playlist of the upcoming video. And let me just inform you about the schedule of these sessions, 9 p.m. daily in the evening. So friends, just like the session, share and subscribe if you have not subscribed till now. Till then, thank you so much for joining me. Entertainment, Sagar, Sukanya, Suraj, all the candidates who were with me in this session, thank you so much for joining me in this session. Take care of yourself, prep smart, score better, go Gradeup. Thank you so much. Thank you.